Hello everybody, this is Kiran. Today we will talk about software defects or bugs and how are they raised. So let's move forward. What is a software bug or defect? So whenever we are testing an application and there is a deviation from the normal workflow, we call it a defect. So it's our responsibility to mark those defects into a tool which we are using, and it has to be assigned to the developer. They needs to be fixed. We have to verify that the bug is fixed or not, and then we have to close the issue. So managing a bug is very important. So you have to make sure that first we understand how to find an issue. Different domains have different kinds of issues, different types of bugs. So having a domain knowledge is very important in knowing and understanding the type of bugs you might get. And also when we are testing, we have to make sure that at the end the system is bug free. So for that we have to understand how to raise an issue, how to retest it, what all matrix we have to follow. So let's see and move forward to understand these. So normally any issues, problems, deviation from the normal flow is called a defect. And when we are reporting the defect, when we are raising the issue, we have to make sure that we are filling in the following fields to mark the bug properly. First is defect ID. If we are marking the issue in a tool like Jira, the defect ID is an automatically created number which will be assigned to the defect and will be associated with it for its unique identification. Suppose we are using an Excel sheet for raising bugs, then in that case we have to explicitly mark some numbers or unique digits associated with the bug so that it can be uniquely identified. Then second point which we have to write in the defect is about defect description. We have to mention what the defect is about, where is the deviation, what is the issue. So we have to write it in a gist so that the developer can read and understand. Then we have the version of the software you are testing. So if we are testing on version let's say 1.0, then we have to mention the build number or release number, because it should be clear that where the tester is testing and where the developer need to fix it. So you have to mention the release or the version number of your software you're working on. Steps to reproduce, very important. Why? Because you have found out some issue and you have to explain that to some other person or the developer in the team. The person needs to perform the steps again and reach to that particular problem or defects. So there should be a proper pointers starting from opening the URL, clicking on a button, perform following set of steps. So steps to reproduce is very important. Date raised. This is an automated field also in the tools, but if you are raising it in Excel again, you have to mark the date raised when we are raising the issue. This is very important to track the progress of the issue as well. Then you have references. So let's say your deviation from the normal flow, you are marking it from some document which you are following, let's say your feature specification or your business requirement document. So you can mark them as reference. If you are finding an issue you got the reference from some internet page, you can mention that as well, or any screenshots, you can mention their links as well. Detected by, it's again an automated field in the tools which you are using. So it's your name where you are the tester, you're raising the issue. The status of the current issue in the bug life cycle. When we learn the bug life cycle, you'll understand about the statuses, different statuses a bug has to go through, starting from new to assigned to fixed to retested to closed. So there are different statuses a bug has to go through. We'll talk about it, but currently you just understand it's a status, current status of the bug. Fixed by is the name of the developer who is going to work upon the bug and who will be responsible for fixing it. Then we have the date closed. The date when you are actually closing the issue after retesting will be the date closed. Then severity and priority. There are two very important terms associated with any bug: severity and priority. Severity means how critical the issue is. It can be a blocker, it can be high, it can be medium, it can be trivial. And priority is associated with a term which means how soon the bug has to be. If it's high, then the bug needs to be fixed ASAP. If it's medium, it can be taken care of in a while, and if it's low, it can wait for a while. So these are the major fields which needs to be filled in while raising any issue. We'll move forward and see what's next we have. So the entire defect management process can be summarized into this diagram. You have to discover a defect. You are actually finding out a defect. So then you categorize it, segregate it into genres, then you resolve it, resolution of the issue happens, then you verify it, that is retest it, then you close it, and then you report the status of the bugs. So we'll go through each of the pointers, starting with discovery of any issues. So you can see whenever a defect is found, is discovered, it needs to be reported and assigned to a concerned developer who will accept the defect and start working on it. So that's about the discovery of any issue. Then we have to categorize it. So the categorization is again based on how severe it is or how soon it has to be fixed. So categorization will be severity and priority marking, critical, high, medium, low. Nomenclatures can vary from project to project, application to application, doesn't matter, but the sense remains same. If it's high priority, it has to be fixed ASAP. If it's a very critical bug, it has to be fixed ASAP. Now, moving forward, resolution. So if we have to resolve the issue, we have to assign it to the concerned developer. The person needs to fix a date when he is going to resolve the issue, and he has to fix the defect and report that yes, the resolution has been done. So you can see all the pointers mentioned here about assignment, schedule, fixing the actual defect, reporting that the resolution has been done. Then we come into picture, verification, wherein we need to retest and make sure that the bug has been fixed as per the requirement. If there is any discrepancy, if we feel that no, the bug hasn't been fixed properly or partially, then we have to reopen it. So verification is very important. Then there is closure of the issue. If the bug has been fixed, it can be closed. If not, then it has to be reopened. Then we have to report the status of all the issues to our managers, because they must know how many bugs are open, how many are closed, how many are still to be taken care of, not fixed, or it's still open. Then they need to know the status of the current bugs in the list. Then there are two very important metrics which we have to understand while working as a tester. They are defect rejection ratio and defect leakage ratio. Now let's understand what is defect rejection ratio. If you're a tester and if you have raised 100 bugs and out of those 20 bugs were rejected, your only 80 bugs has been accepted by the developers and only 80 bugs will be fixed. The 20 bugs which you had raised has been already rejected. So your defect rejection ratio will be 20%. That's not a good number to have 20% of your issues rejected. So you have to make sure that your defect rejection ratio has to be as minimum as possible. So how do we calculate defect rejection ratio? There's a formula which you have to follow. The number of defects which were rejected upon total number of defects raised into 100. So you can find the defect rejection ratio of an individual tester or entire QA team. These matrices helps us keep a track of the progress of the team and the quality the team is working with. So basically your defect rejection ratio has to be very, very less. Most of the bugs which you raise has to be accepted for being a good tester. Now the second matrix which we will talk about here is defect leakage ratio. Now if an application has, let's say, 100 issues existent, so if 100 issues are there and you could only find 70 issues in the system and you missed 30 issues which were there, so the defect leakage ratio will be 30%. How do we find that out? So to find out the leakage ratio of a system, you have to write the number of defects which were missed upon the total in the software, existent in the software, into 100. So again, as a tester, you have to make sure that this ratio is also as minimum as possible, because our goal is to find out maximum issues in the system and make the system bug free. So if we are missing 30% of our defects, it's certainly not a good scenario. So you have to make sure that you raise as much defects as possible. It's always said that exhaustive testing is not possible, but at the same time, being a good tester, we all have to make sure that we are not missing issues in the system. At the same time, our defects are also not rejected. So these two matrix, which is defect rejection ratio and defect leakage ratios, they decide the quality of the testing team we are working on. And at the same time, we all have to make sure that both these ratios has to be as minimum as possible. And again, here we come with the bug life cycle. The bug life cycle are the steps through which the bug has to go through, get closed. So again, as I said, it is new, then assigned, then open, then fixed, then pending retest, then retest, then verified, then closed or reopen. So these are all the phases which a bug has to go through, and you have to make sure that all the bugs are closed before any release. Thank you.